All right, thanks everybody for hanging in there while I reroute a couple of old Zoom meetings to new Zoom meetings. All righty, so tonight we are covering Chapter 7. There's 54 questions total and 27 pages. We're going to do radio measurements and performance, test equipment used in ham radios, oscilloscopes, spectrum analyzers, receiver sensitivity and noise, dynamic range, intercept points, phase noise, transmitter intermod, atmospheric, power line and vehicle noise, and then noise reduction techniques. So the first section 7.1 is all about test equipment. We got 16 questions. So let me move this out so I can see the entire screen and not have to guess what the wording is there. Okay, what is the significance of voltmeter sensitivity expressed in ohms per volt? A, the full-scale reading of the voltmeter multiplied by its ohms per volt rating will indicate the input impedance of the voltmeter. B, when used as a galvanometer, the reading in volts multiplied by ohms per volt rating will determine the power drawn by the device under test. Or C, when used as an ohm meter, the reading in ohms divided by the ohms per volt reading will determine the voltage applied to the circuit. Or lastly, D, when used as an ammeter, the full-scale reading in amps divided by ohms per volt rating will determine the size of the shunt needed.
A.
Alpha is correct. What of the following instruments would be the most accurate for measuring the RMS voltage of a complex waveform? Man, I'm just tongue-tied tonight. A grid dip meter. B, a D'Arsenal meter. C, an absorption wave meter. Or D, a true RMS calculating meter.
Delta.
Delta is correct, a true RMS calculating meter. What is the approximate ratio of PEP to average power in a typical single sideband phone signal? A, 2.5 to 1, B, 25 to 1, C, 1 to 1, or D, 100 to 1?
Alpha.
Alpha is correct, 2.5 to 1. What determines the PEP to average power ratio of a single sideband phone signal? A, the frequency of the modulating signal. B, speech characteristics. C, the degree of carrier suppression. Or D, the amplifier gain?
Bravo.
I hear a bravo out there. Is
Bravo.
correct. Speech characteristics for single sideband phone. What is the purpose of the prescaler function on a frequency counter? Oh wow, it's missing an A. A, it amplifies low level signals for more accurate counting. B, it multiplies a higher frequency signal so a low frequency counter can display operating frequency. C, it prevents oscillation in a low frequency counter circuit. Or D, it divides a higher frequency signal so a low frequency counter can display the input frequency.
Delta.
Delta is correct, and I want to grab a pen and fix Fix E4A05. Letter A. Wouldn't be fun if I didn't have some corrections. Which of the following factors most affect the accuracy of a frequency counter? A. Input attenuator accuracy. B. Time base accuracy. C. Decade divider accuracy. Or D. Temperature coefficient of the logic.
Bravo.
Bravo is correct. The time base accuracy. How is the compensation of an oscilloscope probe typically adjusted? A. A square wave is displayed and the probe is adjusted until the horizontal portions of the displayed wave are as nearly flat as possible. B. A high frequency wave is displayed and the probe is adjusted for maximum amplitude. Or C. A frequency standard is displayed and a probe is adjusted until the deflection time is accurate. Or D. A DC voltage standard is displayed and the probe is adjusted until the displayed voltage is accurate.
Alpha.
Alpha is the correct. Square wave is displayed and the probe is adjusted until the horizontal portions of the displayed wave are as nearly flat as possible. You'll see a bit of an overshoot sometimes until you adjust it, or it'll be, the edges will be rounded off and you want to get it to where it's as close as a good square wave can be. Which of the following is good
Hey,
practice?
go back. That one thing they don't mention anywhere is that you set the time base for a certain point every time, because you can make it look really square if you set the time down, right? But you got to turn the time base to a certain level.
Yeah.
And it's usually specified in the scope manual for the amount of compensation that you want to do at the frequency you're measuring.
Yep. Which of the following is good practice when using an oscilloscope probe? A. Keep the signal ground connection of the probe as short as possible. B. Never use high impedance probe to measure a low impedance circuit. C. Never use a DC coupled probe to measure an AC current. Or D. All these choices are correct.
Alpha.
Alpha is correct. Keep the signal ground connection of the probe as short as possible. Which of the following limits the highest frequency signal that can be accurately displayed on a digital oscilloscope? A. Sampling rate of the analog to digital converter. B. Amount of memory. C. The Q of the circuit. Or D. All these choices are correct.
Alpha.
Alpha is correct. Sampling rate of the analog to digital converter. What is the effect of aliasing on a digital oscilloscope caused by setting the time base too slow? A false jittery low frequency version of the signal is displayed. B. All signals have a DC offset. C. Calibration of the vertical scale is no longer valid. Or D. Excessive blanking occurs, which prevents display of the signal.
Alpha.
Alpha is correct. Which of the following displays multiple digital signal states simultaneously? A. A network analyzer. B. A bit error rate tester. C. Modulation monitor. Or D. A logic analyzer.
Delta.
Delta is correct. A logic analyzer. What is the name of the process that shows that a square wave is made up of a sine wave plus all its odd harmonics? A. Fourier analysis. B. Vector analysis. C. Numerical analysis. Or D. Differential analysis.
Alpha.
Alpha is correct. Fourier analysis. What type of wave does a Fourier analysis show to be made up of sine waves of a given fundamental frequency plus all its harmonics? A sawtooth wave, B, a square wave, C, a sine wave, or D, a cosine wave?
Bravo.
A.
Bravo. Alpha is correct, a sawtooth wave. Which of the following parameters does a spectrum analyzer display on the vertical and horizontal axes? A, RF amplitude and time. B, RF amplitude and frequency. C, SWR and frequency. Or D, SWR and time?
Bravo.
Bravo is correct. The RF amplitude and frequency. Which of the following test instruments is used to display spurious signals and or intermodulation distortion products generated by an SSB transmitter? A, a wattmeter. B, a spectrum analyzer. C, a logic analyzer. Or D, a time domain reflectometer?
Bravo.
Bravo.
Bravo is correct, a spectrum analyzer. Which of the following methods measures modulation distortion SSB transmitter? A, modulate the transmitter using two RF signals having non-harmonically related frequencies and observe the RF output with a spectrum analyzer. B, modulate the transmitter with two AF signals having non-harmonically related frequencies and observe the RF output with a spectrum analyzer. C, modulate the transmitter using two AF signals having harmonically related frequencies and observe the RF output with a peak reading wattmeter. D, modulate the transmitter using two RF signals having harmonically related frequencies and observe the RF output with a logic analyzer.
Bravo.
Bravo is the correct one here. Modulate the transmitter using two audio frequency signals having non-harmonically related frequencies and observe the RF with a spectrum. So you know it's going to be a spectrum analyzer, so you just have to look at which ones, and it's with the AF signals. Boy, there's an eye chart. 23 questions in section 7.2. It's actually fairly large. I should probably shrink that into one. What does a receiver noise floor of minus 174 dBm represent? A, the minimum detectable signal as a function of receive frequency. B, the theoretical noise in a 1 Hz bandwidth at the input of a perfect receiver at room temperature. C, the noise figure of a 1 Hz bandwidth receiver. Or D, the galactic noise contribution to the minimum detectable signal.
Bravo.
Bravo is correct. A CW receiver with an AGC off has an equivalent input noise power density of minus 174 dBms per hertz. What would be the level of an unmodulated carrier input to this receiver that would yield an audio output SNR of 0 dB in a 400 Hz noise bandwidth? A, minus 174 dBm, B, minus 164 dBm, C, minus 155 dBm, or D, minus 148 dBm?
Delta.
Delta.
Delta is correct, minus 148 dBm. What does the MDS of a receiver represent? A, the meter display sensitivity, B, minimum discernible signal, C, multiplex distortion stability, or D, the maximum detectable spectrum?
Bravo.
Bravo is correct. I like how they managed to find something with MDS in every one of those distractors. Why can an attenuator be used to reduce receiver overload on the lower frequency HF bands with little or no impact on signal to noise ratio? A, the attenuator has a low pass filter to increase the strength of lower frequency signals. B, the attenuator has a noise floor to suppress interference. C, signals are attenuated separately from the noise. Or D, atmospheric noise is generally greater than internally generated noise even after attenuation.
Delta.
Oh,
Delta is the correct answer. What is the noise figure of a receiver? A, the ratio of atmospheric noise to phase noise. B, the ratio of noise bandwidth in hertz to the theoretical bandwidth of a resistive network. C, the ratio of thermal noise to atmospheric noise. Or D, the ratio in dB of the noise generated by the receiver to a theoretical minimum noise.
Delta.
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 Delta is the correct answer. Which of the following receiver circuits can be effective in eliminating interference from strong out-of-band signals? A, a front-end filter or preselector. B, a narrow IF filter. C, a notch filter. Or D, a properly adjusted detector.
Alpha.
Alpha is correct. The front-end filter or preselector. What is the purpose of the preselector in a communications receiver? A, to store often used frequencies. B, to provide a range of AGC time constants. C, to increase rejection of signals outside the desired band. Or D, to allow selection of the optimum RF amplifier device.
Charlie.
Charlie is correct, to increase rejection of signals outside the desired band. Which of the following choices is a good reason for selecting a high frequency for the design of the IF in a superheterodyne HF or VHF communications receiver? A, fewer components in a receiver. B, reduced drift. C, easier for front-end circuitry to eliminate image responses. Or D, improved receiver noise figure.
Delta.
Charlie.
Charlie is the correct answer. Easier for front-end circuitry to eliminate image responses. What is an advantage of having a variety of receiver IF bandwidths from which to select. A, the noise figure of the RF amplifier can be adjusted to match the modulation type, thus increasing receiver sensitivity. B, receiver power consumption can be reduced when wider bandwidth is not required. C, receive bandwidth can be set to match the modulation bandwidth, maximizing signal to noise ratio and minimizing interference. Or D, multiple frequencies can be received simultaneously if desired.
Charlie.
Charlie is correct. How does a narrow band roofing filter affect receiver performance? A, it improves sensitivity by reducing front-end noise. B, it improves intelligibility by using low Q circuitry to reduce ringing. C, it improves dynamic range by attenuating strong signals near the receive frequencies. Or D, all these choices are correct. Charlie is the correct answer. It improves dynamic range by attenuating strong signals near the receive frequency. What transmit frequency might generate an image response signal in a receiver tuned to 14300 megahertz, and that uses a 455 kilohertz IF frequency? A, this seems like I got that from last week, didn't I? Or am I getting confused here? No, it is. Yeah, that's last week's.
This is part of this week's stuff.
It's
Good.
part of this week.
Oh yeah, 715. Okay, there we go. Got to look at the page number. Sorry. I thought I cut and pasted the wrong stuff. Okay, so receiver tuned to 14300 that uses a 455 kilohertz. Is it A, 13.845 megahertz, B, 14.755 megahertz, C, 14.445 megahertz, or D, 15.210 megahertz?
Delta.
Delta is correct, 15.20 megahertz. An SDR receiver is overloaded when input signals exceed what level? A, 1/2 the maximum sample rate. B, 1/2 the maximum sampling buffer size. C, maximum count value of the analog to digital converter. Or D, the reference voltage of the analog to digital converter.
Delta.
Charlie is the correct answer on this one. The maximum count value of the analog to digital converter. Which of the following?
You sure about that?
Well, let's double check.
I don't see it.
716. I did cut and paste things, but let me go and pull this up. So 716.
It's out of sequence with what the book, but it's the right answer. A, B, C, D is out of sequence.
Okay.
But it is out of sequence.
Yeah, it says the reference voltage must not be exceeded or the receiver is overloaded. In the top half here.
Okay. Once a signal has been digitized in an SDR, there's no analog circuits to.
No, right above that.
Oh, right above 4.
See where it's. Oh, no, you're right. Keep going. Yeah, read that paragraph.
Yeah.
Once the signal has been digitized.
Yeah, once signal has been digitized in an SDR, There are no analog circuits in its path to distort or otherwise compromise the signal. While that provides superior filtering and rejection of unwanted signals, the analog to digital converter's maximum input signal level, which is set by a reference voltage, is set by the reference voltage, must not be exceeded or the receiver is overloaded. Wow. Yeah, so this has the wrong answer in it from what I'm seeing.
My book has the reference voltage answer marked as correct.
Practice site makes you pick D.
Okay, so the book in the back, E4 CO8.
Correct. Delta.
Well, it makes sense that the A to D just couldn't work over the reference voltage.
Oops, hang on a sec. Yeah, this is wrong. This is D. Because even in the back of the, yeah, this is D. Okay, so good catch. Let's see, from the current slide. That was a good catch. Extra points. So yeah, the reference voltage of the analog to digital converter. Yep. Alrighty. Which of the following has the largest effect on an SDR's receiver dynamic range? A, CPU register width in bits. B, anti-aliasing input filter bandwidth. C, RAM speed used for data storage. Or D, analog to digital converter sample width in bits.
Delta.
Delta.
Delta is correct. The analog to digital converter sample width in bits. What is meant by the blocking dynamic range of a receiver? A, the difference in dB between the noise floor and the level of an incoming signal that will cause a 1 dB of gain compression. B, the minimum difference in dB between the levels of two FM stations that will cause one signal to block the other. C, the difference in dB between the noise floor and the third order intercept point. Or D, the minimum difference in dB between two signals which produce third order intermodulation products greater than the noise floor.
Alpha.
Alpha.
The correct answer is alpha. We double check that. Don't tell me that there's more here. 4D1. Or D1. Well, it says alpha in the back of the book, 717. And it's 720, not 717. Excessive phase noise in a receiver local oscillator allows strong signals on nearby frequencies to interfere with the reception of a weak signal. E4. I'm reading the wrong one, am I? E4D01. E4D01 says, for some reason my slide deck is got a couple of, this is saying 7-20 and I'm looking in the book and it says 717, not 720.
I believe 716 or 717 would be
Yeah,
correct.
okay, there's blocking dynamic range, and it's question D01. Okay. When the blocking dynamic range is exceeded, the receiver begins to lose the ability to amplify weak signals. And it's not. That is so weird. It doesn't really. Oh,
Practice
okay.
site makes you pick A.
Okay, right above that, where I just was reading, it says a receiver's blocking level is the power of the input signal that causes a 1 dB of gain compression. So yeah, alpha is correct.
Yeah, they list it there in the caption to figure 714.
Yep, I see that now. All righty, alpha is the correct answer on this one.
I just looked it up on Google, and Google says blocking dynamic range may actually mean quite different things in different laboratories, just to make it more fun.
Jeez. Well, always be cautious of what's in the internet. Which of the following reduces the likelihood of receiver desensitization? A, decrease the RF bandwidth of the receiver. B, raise the receiver IF frequency. C, increase the receiver front-end gain. Or D, switch from fast AGC to slow AGC.
Alpha.
Alpha is correct. Yeah, I just noticed Daniel's not on here. Somebody's kitty's on here,
Cat.
though.
Are you the cat, Jim? Are you the cat?
No, I wasn't the cat.
Animal?
There's the cat. Steve has the cat. Hello, kitty. What
Aspen.
is the term for the reduction in receiver sensitivity caused by a strong signal near the received frequency? A, desensitization. B, quieting. C, cross modulation interference. Or D, squelch gain rollback.
Alpha.
Alpha.
Alpha is correct. Desensitization. What transmitter frequencies would cause an intermodulation product signal in the receiver tuned to 146.70 megahertz when a nearby station transmits on 146.5? Is that 5.2? Yep, move that over a little bit. Oops, and now I just clicked too many times. 146.34 megahertz and 146.61 is alpha. Bravo is 146.88 megahertz and 146.34. Charlie is 146.10 megahertz and 147.30 megahertz. And Delta is 173.35 megahertz and 139.40. Who's Yep, alpha is correct. 146.34 and 146.61. Why are odd order intermodulation products created within a receiver of a particular interest compared to other products? A, odd order products of two signals in the band of interest is also likely to be within the band. B, odd order products overload the IF filters. C, odd order products are an indication of poor image rejection. Or D, odd order intermodulation produces 3 products for every input signal within the band of interest?
Alpha.
Alpha is correct. Which of the following describes problems caused by poor dynamic range in a receiver? A, spurious signals caused by cross-modulation and desensitization from strong adjacent signals. B, oscillator instability requiring frequent retuning and loss of ability to recover the opposite sideband. Or C, cross-modulation of the desired signal and insufficient audio power to operate the speaker. Or D, oscillator instability and severe audio distortion of all but the strongest received signals.
Alpha.
Alpha is correct. What does a third order intercept level of 40 dBm mean with respect to receiver performance? A, less than 50 dBm will not generate audible third order intermodulation products. B, the receiver can tolerate signals up to 40 dB above the noise floor without producing third order intermodulation products. Or C, a pair of 40 dBm input signals will theoretically generate a third order intermodulation product that has the same output amplitude as either of the input signals. Or D, a pair of 1 milliwatt input signals will produce a third order intermodulation product that is 40 dB stronger than the input signal.
Charlie.
Charlie is the correct answer. The longest answer. Wow. Workout time. What is an effect of excessive phase noise in a receiver's local oscillator? A, it limits the receiver's ability to receive strong signals. B, it can affect the receiver's frequency calibration. C, it decreases receiver third order intercept point. Or D, it can combine with strong signals on nearby frequencies to generate interference.
Delta.
Delta.
Delta is correct. It can combine with strong signals on nearby frequencies to generate interference. What is reciprocal mixing? A, 2 out-of-band signals mixing to generate an in-band spurious signal. B, in-phase signals canceling in the mixer resulting in loss of receiver sensitivity. C, 2 digital signals combining from alternate time slots. Or D, local oscillator phase noise mixing with adjacent strong signals to create interference to desired signals.
Delta.
Delta is correct. The longest answer. I like that. What is the term for the suppression of an FM receiver of one signal by another stronger signal on the same frequency? A, desensitization. B, cross-modulation interference. C, the capture effect. Or D, frequency discrimination.
Charlie.
Charlie is correct. The capture effect. Hoi, 7.3, 15. We're almost done. 15 questions in this one. All right. How can intermodulation interference between two repeaters occur? A, when the repeaters are in close proximity and the signals cause feedback in the final amplifier of one or both transmitters. B, when the repeaters are in close proximity and the signals mix in the final amplifier of one or both transmitters. C, when the signals from the transmitters are reflected out of phase from airplanes passing overhead. Or D, when the signals from the transmitters are reflected in phase from airplanes passing overhead.
Bravo.
Bravo is the correct answer. Which of the following may reduce or eliminate intermodulation interference in a repeater caused by another transmitter operating in close proximity? A bandpass filter in the feed line between the transmitter and receiver. B, a properly terminated circulator at the output of the repeater's transmitter. C, utilizing a Class C final amplifier. Or D, utilizing a Class D final amplifier.
Bravo.
Bravo.
Bravo is correct. A properly terminated circulator at the output of the repeater's transmitter. What is the term for spurious signals generated by the combination of two or more signals in a non-linear device or circuit? A, amplifier desensitization. B, neutralization. C, adjacent channel interference. Or D, intermodulation.
Delta.
Delta is correct, intermodulation. What causes intermodulation in an electronic circuit? A, too little gain. B, lack of neutralization. C, nonlinear circuits or devices. Or D, positive feedback.
Charlie.
Charlie is the correct answer. Nonlinear circuits or devices. What could cause local AM broadcast band signals to combine to generate spurious signals in the MF or HF bands? A, one or more of the broadcast stations is transmitting an overmodulated signal. B, nearby corroded metal joints are mixing and re-radiating the broadcast signals. C, you are receiving skywave signals from a distant station. Or D, your station receiver IF amplifier is defective.
Bravo.
Bravo.
Bravo is correct. Nearby corroded metal joints are mixing and re-radiating the broadcast signals. How can radio frequency interference from an AC motor be suppressed? A, by installing a high-pass filter in series with the motor's power leads. B, by installing a brute force AC line filter in series with the motor leads. C, by installing a bypass capacitor in series with the motor leads. Or D, using a ground fault current interrupter in the circuit used to power the motor.
Bravo.
Bravo is correct. Installing a brute force AC line filter in series with the motor leads. What might be the cause of a loud roaring or buzzing AC line interference that comes and goes at intervals? A, arcing contacts in a thermostatically controlled device. B, a defective doorbell or doorbell transformer inside a nearby residence. Or C, a malfunctioning illuminated advertising display. Or D, all these choices are correct.
Delta.
Delta.
All of them.
All of them are correct. Which of the following can cause shielded cables to radiate or receive interference? A, low inductance ground connections at both ends of the shield. B, common mode currents on the shield and conductors. C, use of braided shielding material, or D, tying all ground connections to a common point resulting in differential mode currents in the shield?
Bravo.
Bravo.
Bravo is correct. Common mode currents on the shield and conductors. What current flows equally on all conductors of an unshielded multi-conductor cable? A, differential mode current. B, common mode current. C, reactive current only. Or D, return current. Correct answer is bravo, common mode current. What is one type of electrical interface that might be caused by a nearby personal computer? A, a loud AC hum in the audio output of your station receiver. B, a clicking noise at intervals of a few seconds. C, the appearance of unstable, modulated or unmodulated signals at specific frequencies. Or D, a whining type noise that continually pulses off and on.
Charlie.
Charlie.
Charlie is correct. How can conducted and radiated noise caused by an automobile alternator be suppressed? A, by installing filter capacitors in series with the DC power lead and a blocking capacitor in the field lead. B, by installing a noise suppression resistor and a blocking capacitor in both leads. C, by installing a high-pass filter in series with the radio power lead and a low-pass filter in parallel with the field lead. Or D, by connecting the radio's power leads directly to the battery and by installing coaxial capacitors in line with the alternator leads.
Delta.
Delta is the correct answer.
Can you know if it's conducted or radiated noises? Is that just when you transmit?
I can barely hear you. What was it?
How do you know if it's radiated noise or conducted noise that you're trying to suppress?
I still got some background noise. How do you know?
How do you know it's conducted or radiated? And what's the symptom? Is that just when you transmit, it's causing noise, or?
Actually, when you're receiving stuff, you would hear the noise in the car's alternator. So when you're driving and you're at different speeds, you could hear in the radio, you almost hear that whining noise coming
From the
back
RPMs
and forth.
of the.
Yeah.
I got you.
Yeah, because I remember back in the CB days, that used to be a common issue that you could hear when you were driving, you could hear the buzz and noise, and so they would hook up the power leads directly to the battery and have the coaxial capacitors.
If you have your antenna on your radio disconnected and you still hear the noise, I believe that would qualify it as conducted noise coming through the power supply.
Yeah, that'd be true.
I can hear that in my AM radio sometimes.
Yep. Okay, what problem can occur when using an automatic notching filter, or an ANF, to remove interfering carriers while receiving CW signals? A, removal of the CW signal as well as the interfering carrier. B, by nearby signal passing through the DSP system will overwhelm the desired signal. C, received CW signals will appear to be modulated at the DSP clock frequency. Or D, Ringing in the DSP filter will completely remove the spaces between the CW characters.
Alpha.
Alpha.
Alpha is correct. Removal of the CW signal as well as the interfering carrier. Which of the following types of noise can be reduced with a digital signal processing noise filter? A. Broadband white noise. B. Ignition noise. C. Power line noise. Or D. All these choices are correct.
Delta.
Delta is correct. All of these are correct. Which of the following signals might a receiver noise blanker be able to remove from desired signals? A. Signals that are constant at all IF levels. B. Signals that appear across a wide bandwidth. C. Signals that appear at one IF but not another. Or D. Signals that have a sharply peaked frequency distribution.
Bravo.
Bravo is correct. Signals that appear across a wide bandwidth. What undesirable effect can occur when using an IF noise blanker? A. Received audio in the speech range might have an echo effect. B. The audio frequency bandwidth of the received signal might be compressed. C. Nearby signals may appear to be excessively wide even if they meet emission standards. D. FM signals can no longer be demodulated.
Charlie.
Charlie is correct. Oh, dib, 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 dib. That's all, folks. Wow. That was a fun chapter. I learned a lot today watching the OG things and the whole IMD and dynamic blocking and all of that. This was a first one that was really starting to sink in, but a lot of stuff was still feeling like it's going over my head. I think it's because I'm doing all three classes and getting confused.
You mean you're getting overloaded, Jim?
Yeah. The analog to digital converters got an overload.
Well, thank you.
But the good news is the technician ends next Sunday and the general ends next Wednesday. So I can focus on the last few chapters of the extra. So I mentioned this earlier in looking at where we're at. So we just finished up chapter 7. So chapter 8 we'll be doing on March the 4th. Chapter 9 we'll be doing March the 11th. And I was mentioning that chapter 10 and 11 are kind of short. So I'd like to go ahead and put those two together. It would end up being 56 questions and about an hour and a half worth of video. And that way we could wrap up on March the 18th. So that's my current thoughts, because the rest of these have lots of questions. So I
Sounds reasonable to me.
think that's what we'll give it a shot. Any questions on what we just covered, or?
Jim, any idea when the test would be given?
So if we go with the March 18th as the last date, we'll start looking at, let me bring up the calendar. So probably the week of the 21st, March 21st through the 27th. I'll see if he has any. I'm going to work with Scott and see where we are with because he's already doing the technician and the general guys, and they're trying to get them done the 7th through the 13th. So I'll see if we can do like a Saturday, Sunday, or maybe it'll be during the week of the 21st to the 27th. And then
Okay.
Daniel was also, and I don't know how this is going to work, but he's also trying to get a place in Ballard to where we can do in person with protection and all of that fun stuff, and
Great.
try to get some stuff going there too.
Great.
Yep.
Yeah, there's a place right across from Larson's Bakery where I took my general there. It's a Korean church downstairs, and the ham testing was upstairs.
Yeah.
Yep.
That's the place that I think Daniel is talking with to see if we can't do in person testing there, because the online stuff with Scott, you have to get 4 other VEs and do it on Zoom and all of that fun stuff, and he's trying to shrink the time down to such a small, like a half hour, 45 minutes, and no, you don't want to be pressured into time. You want to be able to focus and take the time that you need to get through this test. So hopefully we'll work something out with Daniel and get that place there in Ballard. We all might be going to church, right? At 25% capacity, and we'll pray that we're
I was
passing.
going to say, we're going to pray a lot.
Yeah,
Jim.
we're going to be doing a lot of praying that we're passing the. I don't know how. That's the thing. I mean, with the whole COVID stuff and locking down and being safe, and you want to be safe. You don't want to pick it up, but at the same time, it's wow. Everything is just crazy trying to schedule stuff.
Hey, have we had some people drop out? Looks like a lot fewer people this week.
Yeah. I've been seeing a slow decline on our participation, but I thank you for sticking with us. The ones that are here tonight, I really appreciate it. You know, I'm hoping that we can continue. I think, I don't know, life happens,
Yeah.
and you know, I'm here. Yeah, granddaughter's in the other room. You may have overheard some giggling and things, but since we're in the COVID stuff, trying to spread it out a little bit. Somebody told me that might not be a good idea to spread it out.
No, it's a bad choice of words.
Yeah.
Right. Well, we thank you.
Yeah. Thank you guys for working hard on it. I know it's fun stuff to keep up with. All righty. If there's nothing else, I'm going to stop.
Thank you, Jim, for doing it.
Yeah.
Pray for Jim.
All righty. Thank